Hi everyone, let's solve product of array except self. This problem, given an integer array nums, return an array answer such that answer of I is equal to the product of all the elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. You must write an algorithm that runs in big O of n time and without using division operation. So let's take this example nums. So what they are trying to say is that let's say I is equals to 0 and value in that place is 1. What they're trying to say is that answer of 0 will be, so let me also put an answer array. Answer of 0 will be 2 into 3 into 4, right? Except this index, we have to iterate over all the elements. 2 into 3 into 4, it's nothing but 24. So we will insert our answer. Now next iteration, I is equals to 1, index 1, value is 2. So answer of 1 will be 1 into 3 into 4. Nothing but we just have to skip this element. It's nothing but 12. Similarly, I is equals to 2, value is equals to 3. Answer of 2 is equals to 1 into 2 into 4. And this answer will be 8. So we just have to also insert, like, just to for understanding here. Now our index is 3, value is equal to 4. Answer of 3 is equals to 1 into 2 into 3, 6. So this is what happens, right? The answer here will be 6. So how do we iterate over all the elements? We just run a for loop, and for every index, so there will be an outer loop which runs from 0 to n minus nums dot length minus 1, and also we will get every element except that and multiply it. So let's code this up. So we should just skip that element. If index I not equal to j, only then we just have to multiply it. So let product equal to 1. So here again we should ensure that the initialization value is 1 and not 0, because 0 into anything will be 0. Product equal to product into nums of I. This is what we get. And now once we multiply all the numbers except that index value, then we will push into our answer array. I hope this is clear. Now let's return. Let's submit this, but as we all know, we want big O of n solution and not big O of n square, because this is n time, and for every index it will again run for n times, so it's an n square solution. But let's try. Okay, yeah, I just made a spelling mistake. Let's understand where we went wrong. So product nums dot, okay, this should be j, right? We just have to iterate over all the elements, rest of the elements, right? Let's submit it. Yeah, we will get TLE because of the constraints which we have here. Now let's come up with a optimal solution. Let me get rid of this. Let's copy the example again. And now let's say somehow I have a prefix product and I have a suffix product. So when I say prefix product, it's product of all elements till that number, till that index, except that index. Okay, I'll show you with the example. Product of all till that index, product of elements from that index till last. So this is the representation. Now let's understand. So if I am here, there is no prefix sum, it's fine. But when I am here, I know that the prefix sum should be 1. Right? When I am here, the prefix sum, what will be the prefix sum till here? It will be, prefix product till here. 1 into 2 is nothing but 2. And prefix product till this, 2 into 3, 1 into 2 into 3, 6. Prefix product till this elements, 1 into 2 into 3 into 4, nothing but 24. Now similarly, from the backward, 4 will be the, 4 will be the final element. 4 into 3 will be 12. 4 into 3 into 2 will be 24. 4 into 3 into 2 into 1, 24. Right? This is the suffix product. So if you observe, product of all elements till that index. So product of elements till that index, product of all the elements till that index. So wherever, if I am here, I have the product of all the elements till that index. That is what prefix product represents. And the suffix product is nothing but, if I am here, I just got from that index till the last the product. So if I am at this position at 3, I have the product of this element till the last elements. 3 into 4 is what I have here. Let's say, for example, I want to know the product of rest all elements before this. What can I do? I can take prefix product of I minus 1, which is nothing but prefix product till the previous element, and I can take suffix product of I plus 1 because it will represent the product of all the elements after that index. So if I have to take my answer of I, it is nothing but prefix of I minus 1 into suffix product of I plus 1. That is all it is. Now there are some conditions. If I is equals to 0, 0 minus 1 will be out of bounds, right? So we will not be able to access. Similarly, if I is equal to the length of the nums.length minus 1 plus 1 is not accessible to us. So we should just check those conditions. I hope this is clear. Right? Now let's try to build our answer from the given array. So when I am here, if I am at this particular position, the prefix product of I minus 1 will not be available. So let's consider that as 1 into, what should I do? Suffix product of I plus 1, nothing but 24. So I will take answer as 24. Now when I am here, I have to take prefix product of I minus 1 into suffix product of I plus 1. It would be 12. When I am here, I have to take prefix product of I minus 1 is 2 and suffix product is 4, nothing but 8. And when I'm at the end, prefix product in prefix product of I minus 1 is 6. Suffix product of I plus 1 is not available. So we should consider it as 1, right? Then the answer will be 6. So basically what I'm trying to say is, we can also add checks. If I double equals to 0, we just have to multiply it into 1, else we will give the prefix product of this. If I is equals to nums dot length minus 1, nothing but the last index, then I will also return 1, else this. So basically this is the conditional checks we have to do. Now let's try to code it up. So first we have to calculate prefix product, then we will have to calculate the suffix product, and then we are calculating the answer and then returning. So so any which ways answer will be there. So I'm just removing the other code. Now I will let prefix product, let suffix product. So if I is equals to 0, prefix product of I is equals to nothing but nums of I. Basically we can also consider it as okay, yeah, it should be nums of I. We are just calculating. And then if it is not the case, what can we do? We just have to do prefix product of I minus 1 into nums of I. So this is the calculation how we do the prefix product. Basically when I am at this index, prefix product of I is 1 because there is no element before that. But when I am here, if I have to get the prefix product at this index, I will have to multiply prefix product of I minus 1 into nums of I. That's when I get this product. Then when I am here at 3, I have to multiply prefix product of I minus 1 into the current element. That's when I will get the 6. So this is basically optimization of multiplying all the numbers. We just have that elements product in the previous index. We are just taking that product and we are multiplying with the current element. So that's all we are trying to do. So if you see, I minus 1 is, if you read the representation, it is product of all the elements till I minus 1, and we are multiplying our current element. So that's how we will get the prefix product of I. Similarly, if we will also calculate our suffix. Okay, for suffix product we have to iterate in the reverse order because we will be depending on, if I am at 4, this will be 4 itself, but when I am here, my suffix product will be I suffix product of I plus 1 into nums of I, right? So let me also calculate that. Nums dot length j is greater than or equal to 0 and j minus minus. So if j, sorry, okay, I have taken it as a j. Okay, it's fine. J is equals to nums dot length minus 1, nothing but the last index. What should I do? Suffix product of j should be nums of j, else suffix product of j should be suffix product of j plus 1 into nums of j. So basically we can take it as j or I, it should not matter, this is just a variable. Now both the suffix and prefix products are ready. Now we will have to calculate our answers. So when I have to calculate answer, what is my answer? Answer of I is equals to the same condition which I have written here, right? Basically prefix product of I minus 1 into suffix product of I plus 1 is what will give us the answer, but we are just checking the bounds and returning 1 if it is not within the bounds. That's it. Now let's try to run it and see. Yes, it's working fine. Now let's also submit it. Yes, it's working fine. Now let's also think of one more optimization. So if you see in the answers and prefix product calculation, we are iterating from the start till the end. So let me give you an example. Instead of maintaining an array, can I do prefix product initially 1 and 1 into 1 will be 1, and now 2 into 1 will be 2. So if I have to get the product of at the index 2 at the value 3, what should I do? Prefix product so far, which I already have, and suffix product is already there in the array. I can just multiply 2 into 4, right? that is how I will get the answer 8. So instead of having a array, can I just combine these calculations is what we are trying to do. So let's try to combine these calculations. Let me show you. So instead of having the prefix product was 1, right? So instead of that, I will do prefix product equal to prefix product into nums of I. That is all what we were trying to do here, nothing else, right? Instead of storing it somewhere, now what I'm trying to do is this part. So basically how it works is, let me show you with the we already have a suffix calculation because we are not removing that part. So we have this. Now what I'm trying to do is, my prefix product is 1. So now my answer is nothing but, when I is equals to 1, prefix product into suffix product of I plus 1. Suffix product of I plus 1 is nothing but 24 into 1 will give me answer 24. Now when I am done with this, I will multiply my prefix product into 1. It will be 1 again. Now when I am here, I already know prefix product till this elements, which is 1. Now I will pick up suffix product till here, nothing but 12. So prefix product into suffix product of I plus 1 will give me answer 12. And then when I am here, before moving to the next element, I will multiply the current element with the prefix product, nothing but it's 2. Now when I'm here, I will calculate prefix product into suffix product of I plus 1. It will be 8. Now again when I'm here, the answer is simple. So okay, I also have to multiply 2 into 3, which will be 6. When I'm at the last index, as we all know, if we are at the last index, we are just going to write 1 into 6 will be 6. So this is how we get the answer. Now let's try if this will work. Yes, it will work. So let me explain you all the solutions which we discussed. Initially we have created for every element we have iterated over all the elements and skipped that particular index, and the time complexity of that was big O of n square, and then the space complexity over there was big O of 1. If we are like neglecting the answer part, if not the answer, it is space complexity of big O of n. Then we discussed a solution with pre-calculating prefix product and suffix product, and the time complexity of the solution is big O of n plus n plus n. Because one is for calculating the prefix product, one is for suffix product, and the other one is for the solution answer calculation. Space is big O of n plus n, so nothing but n overall. And then the other solution which we discussed is in prefix product, instead of array, we calculated on the fly while calculating answer. That is all we are trying to do. So basically, while we are computing the answer itself, we are also calculating the prefix product, because we are iterating on the same array, so we will be able to have the answers. We just have to calculate the answer and then include it into the prefix product. That is all we are trying to do. And the time complexity of this solution is that big O of n plus n, because we are just calculating the suffix product and then we are calculating our answer. then the space complexity of this solution is big of just n, because we are using it for suffix product, and also if you consider for answer it will be plus n. Again here also if you consider for answer array it will be plus n, but yeah, overall it will be big of n and also big O of n. So this is the solution. I hope you guys understood. Thank you.